Okay guys, so let's just check if this is working. Yes it is. This is our final ACT Science video. Okay, so let's start. Salts containing nitrite ions, NO2-, are often added to meats to prevent discoloration caused by air and bacterial growth. Use of nitrate is controversial because studies have linked nitrate with cancer. Students performed 2 experiments to measure nitrate levels. Experiment 1. 4 solutions, let's get a magnifier on this. 4 solutions, each containing a different amount of NaNO2, a salt, is in water, were prepared. A coloring agent was added that binds with nitrate to form, nitrite to form a purple compound that strongly absorbs light of a specific wavelength, and each solution was diluted to 100 milliliters. A blank solution was prepared in the same manner, but no sodium nitrite was added. A colorimeter, a device that measures how much light of a selected wavelength is absorbed by a sample, was used to measure the absorbance of each solution. The absorbances were corrected by subtracting the absorbance of the blank solution from each reading. So here's the concentration of Na2 in NO2-, which is nitrite, in ppm, measured absorbance, corrected absorbance, and ppm is parts per million. And experiment 2. A 100-gram meat sample was ground in a blender with 50 milliliters of water, and the mixture was filtered. The blender was remaining meat were then washed with water. These washings were filtered, and the liquid was added to the sample solution. The coloring agent was added, and the solution was diluted to 100 milliliters. The procedure was repeated for several meats, and the absorbances were measured. So we have several meats: hot dog, bologna, ground turkey, ham, and bacon. Corrected absorbance is 0.667, 0.561, 0.030, 0.940, 0.773. And the concentration of nitrite is 4.4, 3.7, 0.2, 6.2, and 5.1. Based on, okay, let's look at this first question. Number 35. Based on the results of experiment 1, if the concentration of NO2- or nitrite in a solution is doubled, then the corrected absorbance of the solution will approximately So let's look at this. Concentration of NO2 in parts per meter and the corrected absorbance. Based on the results of experiment 1, if the concentration of nitrite solution is doubled, then the corrected absorbance of the solution will approximately, well, if we double this, let's say we go from 2 to 4 for the concentration, then the solution does seem to approximately, the corrected absorbance does seem to approximately double, because we've got 0.3 over here for the corrected absorbance, and then we've at 0.3 for corrected absorbance it's 2 ppm, and then when we go to 4 ppm over here it's 0.6 for corrected absorbance, which is double 0.3, so the answer is C, it should double. 36. A sample of pastrami was also measured in experiment 2, and its correct absorbance was determined to be 0.603. Which of the following correctly lists bologna, bacon, and pastrami in decreasing order of concentration? So what we have to do first is try to find the relationship between corrected absorbance and concentration. As you can see over here, this is corrected absorbance. As the corrected absorbance increases, concentration also increases. So, if the corrected absorbance is 0.603 for pastrami, bologna, bacon, and pastrami, right? So bologna is 0.561. Pastrami is 0.603, and bacon is 0.773 in correct absorbance. And remember, as corrected absorbance increases, so does concentration. So it's bologna, pastrami, and then bacon. The answer is H. Based on the results of experiment 1, if a solution with a concentration of 1.5 ppm nitrite had been tested, the corrected absorbance would have been closest to which of the following values? So let's go back to the results of experiment 1. Based on the results of experiment 1, if a solution with a concentration of 1.5 ppm nitrite had been tested, the corrected absorbance would be closest to which of the following values? So as we mentioned earlier, as corrected absorbance increases, so does concentration. But let's look at this clearly. We have one concentration, 1 ppm, and then we have 2 ppm. So it has to be between the corrected absorbance has to be between 0.153 and 0.302. It can't be 0.15. It can't be 0.36 because that's over 0.302. It technically can be 0.30 because it's less than 0.302, but it's at least likely because it's like 1.5, between 1 and 2. It's not likely to be 0.30. It's more likely to be 0.23. So B is our correct answer for that one. If experiments 1 and 2 are repeated using a different coloring agent that produces a different color when it binds with nitrite, then which of the following changes in procedure would be necessary? Let's repeat that. If experiments 1 and 2 were repeated using a different coloring agent that produces a different color when it binds with nitrite, which of the following changes in the procedure would be necessary? The new coloring agent should be added to the blank solution but not to the sample solution. Both the coloring agent should be added to the blank solution and to all the samples. The absorbance of the blank solution made with the new coloring agent should be added to the measured absorbances. The colorimeter should be set to measure at different wavelengths of light. If it produces a different color, I believe that the colorimeter should be set to measure at a different wavelength of light, and that should be the only change. Let's look at it. The answer for number 38 is J. I was right. All the other answers is gibberish. It's like the new coloring agent should be added to the blank solution but not to the sample solutions. That doesn't make sense because it's a blank solution. both of the coloring agents should be, blank solution is controlled, by the way. Both the coloring agent should be added to the blank solution and to all of the samples. That doesn't make sense. Then we lose our control. The absorbance of blank solution made with the new coloring agent should be added to the measured absorbances. I don't know what that means, but that's gibberish too. You can narrow your answer down to J. Okay, so let's do number 39. Based on the results of experiment 1 and 2, if measured absorbances for the meats tested in experiment 2 were compared with the corrected absorbances, the measured absorbances would be, let's look at this, experiments 1 and 2. Higher for all the meats tested, lower for all the meats tested, lower for some of the meats tested, higher for others, the same for all the meats tested. Okay, let's look at this. Measured absorbances for table 1. 0.129, 0.282, 0.431, 0.729, and 0.349. The corrected absorbances are all less than this. 0.000, 0.153, 0.302, 0.600, and 1.220. Now for the meats, the corrected absorbance is 0.667, this, so the measured absorbance would be higher for all the meats tested. The answer should be A. Let's check though. 39 is A, yep. We are on to our final question. Yay! How does it feel? If some of the water-soluble contents found in all of the meats tested in experiment 2 absorb light of the same wavelength as the compound formed with nitrite and the coloring agent, how would the measurements have been affected? Compare the actual nitrite concentrations the nitrite concentrations apparently measured would be. Okay, if some of the water-soluble contents found in all of the meats tested in experiment 2 absorb light of the same wavelength as the compound formed with nitrite and the coloring agent, how would the measurements have been affected? Compared to the actual nitrite concentrations, the nitrite concentrations apparently measured would be, so let's look at experiment 2. The results of experiment 2 are in table 2. So let's reread this. If some of the water-soluble contents found in all the meats tested in experiment 2 absorbed light of the same wavelength as the compound formed with nitrite and the coloring agent, how would the measures have been affected? Compared to the actual nitrite concentrations, the nitrite concentrations apparently measured would be, it should be higher, because if it absorbs the light, if there are water-soluble contents that absorb the light, the and this light device is used to measure the concentration in parts per millions, then water-soluble devices would only cause the measured absorbance to be higher. So let's check. 40 should be F. Let's see. Yep, I was right. 40 is F. That's good. Okay, so this is our final science tutorial. I hope you guys enjoyed it. Feel free to message me on Facebook or email me at debarshikunduzero@gmail.com. Eventually, I plan on doing reading, ACT reading, and ACT English tutorials. Thank you very much, and have a great day.